Well, in the next video, we will see how you can maximize the volume of a container as it is here, of a box. It says that an open box will be produced at the top of a square piece of cardboard. Cutting a square of each corner and folding the sides in the figure, we can see that the piece measures 40 centimeters in total. The next thing is to see that a square piece was removed in each of the corners. That is the one that we do not know until now. We can place it here then, that it was removed X in each corner to its original length. When folding the box, we realize that the tab should measure 40 centimeters minus 2 times X, because an X was removed above, and an X was removed at the bottom, so that this makes sense. The highest value that X could have is going to be 20, because 40 minus 20 is 0. At that moment, the box would cease to exist. Now we must raise it in the following way. We know that it is a square. Therefore, here we are going to have 40 minus 2x minus 2x, and we know that the height is going to be x. To find our volume, it says that we are going to multiply the length by the width, but they are the same. So I could place them as a square 40 minus 2x squared multiplied by x We can develop that equation as long as we make the indicated products. They are telling us that here we have the square of a binomial. Therefore, we are going to develop it. We know that 40 times 40 is going to give us a total of 1600. So I'm going to write here in the parenthesis 1600. Then it tells us minus the double of the first by the second 2 by 40 is 80 by 2 is 160 x plus the square of the second, that would become 4x squared. All this multiplied by x here again. We can observe that this function makes sense as long as x is in an interval between 0 and 20, because if we subtract 40 minus 2 multiplied by 20, this will become 0 multiplied by 20 will continue to be 0 is the minimum volume. There cannot be a negative volume. So we write our interval in which the function is continuous. We now develop the bottom part of the volume where it says that we are going to multiply x by each of these terms. It will be 1600 multiplied by x is 1600x minus 160. X by x is 160x squared plus 4x squared by x is 4x cubed, thus having our function of the volume that can be derived and equal to 0 if we get the first derivative, now the prime of x. We are going to obtain the following. In 1600, it remains as a constant. Remember that the x has a 1, not by 1600, the x disappears minus 2 times, 160,320, and we subtract a unit to the exponent. And finally, plus 3 times 4 is 212x. And we subtract a unit there. We have our first derivative and the equality. Factorizable, we could get a factor like a 4. And within our parenthesis, it would be 12 between 4 is 3x squared. We say 320 here. And finally, we say 1600 divided by 4, that will give us a total of 400. All this equal to 0. Now the 4 that is multiplying here, we can go down to divide by 0, and it will be nullified. 0 between 4 is 0. Therefore, we will only have that 3x squared minus 80x plus 400 is equal to 0. It seems that we have now reached a trinomial of the form x squared plus x plus c. However, this cannot be factorized for that case, but we can make division of factors to try to form groups that give us compound bases and be able to factorize it as a common factor. Let's see, please. Here we could leave the 3x squared, now the minus 80. We can separate it into two parts, one that is going to become minus 20x, and the other that is going to become minus 60x. We are actually writing the 80x, but we are writing it separately. And finally, plus 400 when we have that. And it is equated to 0. We can factorize now grouping. We leave in the first group 3x squared minus 20x, and in the second group, as we place a negation before the signs that enter. So it would become a 60x minus 400. When we factor, it will be as follows. When we factor, we will find then that the common factor of the first group is x. Therefore, within the parentheses, we will only have a 3x minus 20x. Between x, we will only have 20 in the other group. We will find the common factor 20. And if we divide 60x by 20, it will become 3x, and 400 by 20 will become minus 20x. B20 in the other group, we are going to find a common factor 20. And if we divide 60x by 20, it will become 3x. And 400 by 20 will become 20. We have again a common factor. We have a simple base and a base compound, a coefficient and a compound base. And we realize that the base compound is the common factor 3x minus 20. Now when dividing x by 3x minus 20 between 3x minus 20, we will only have the value x minus, and when we divide 20 by 3x minus 20 between 3x minus 20, they will be annulled, and we will only have the value 20. This is equal to 0, obtaining as a result then that if we go to divide the x minus 20, the first one will be that x will be equal to 20, which is now positive, divided by 3. And in the second we will have that x is equal to 20 positive, thus obtaining the critical values of our equation. Any of these two values will be the result of x. However, if we realize 20 when evaluating it in the equation in the original function, I had 40 minus 2 by 20, which would be 40. This is a 0 squared is 0, and 0 by 20 is 0. So we rule out the value 20 has to be smaller than 20. And it is the 20/3 we could write it here as an answer. X should be worth 20. Thirds. Now they ask us what is the value of the volume. The result will be the following: 128,000 divided by 27, and we must not forget the dimensional that was in cubic centimeters. Which could be described as a decimal, but approximate of 4,740.74 cubic centimeters. The box we are going to see, we know that x is worth 20/23, so we are going to write it here, and then it says that 40 minus 2 times 20/3 is going to give us the length and width also. And then it says that 40 minus 2 times 20/3 is going to give us the length and width that are identical. And with that, the problem is solved. If we wanted to make the check that this is actually a maximum, then we should get the second derivative of the function of the volume that will give the following. The 1600 disappears automatically because it is constant. 1 times minus 320 will become minus 320. Then we say that 2 times 12 is 24x to 1. When substituting in the second derivative, the result is negative. It gives us minus 160. So we say that when evaluating 20/3 in the second derivative, the value is less than 0. And that indicates that the value we obtained is a max.